are graphing lines. You should know how to graph lines by now. We spent a lot of time on it, and you've been doing it for 6 years. Okay. All right. Number one's in y equals mx plus b form, where I even wrote it out for you. M's the slope and b's the y-intercept. So, looking at our equation here, my b is positive 4, my y-intercept, and my slope is negative 1/2. I could put it with the 1, or I can put that negative sign with the 2. Plot my y-intercept, which is 4. I'm going to use negative 1 to the right 2, negative 1 to the right 2. Got 3 points. If you got yourself a straight edge, that's the best thing to use. Otherwise, you're going to have to plot a lot of points and do it. There's my line. Now, the last quiz that we had, I had you guys compute what the x and y intercepts were. That was a real big train wreck. I think there were only like 2 or 3 students that got it right. So this time I'm giving you the intercepts. You don't even have to compute what they are. The x intercept is negative 4. So on the x axis, it's negative 4. On the y axis, it's negative 2. Here's my 2 points. Draw my line. So that's drawing lines. Equations of linear equations. All right. Number 3, we're solving systems of linear equations, right? And we had 3 methods: graphing, substitution, and elimination. And within each one of those methods, after we're done with the problem, we had to determine which scenario it was in, right? Whether it was exactly 1 point, no solution, which is parallel lines, or infinitely many solutions, which is the same line. So number 3, we're supposed to solve this system by graphing. So we have to graph each one of these lines. That's why we reviewed how to graph lines. So I'm going to graph the first line. So my y-intercept is 3. My slope is the coefficient of x, which is 1/3, or negative 1 over negative 3. So I'm going to graph that line. See, crosses my y-axis at 3. I'm going to go up 1 to the right 3, or down 1 to the left 3. On my line. Oops, that's a little off. Still off. Then graph the other line. My y-intercept is negative 3 this time. My slope, the coefficient of x, negative 5/3, so I can use negative 5 over 3 or 5 over negative 3. Go ahead and plot or make this line. Negative 3. Now I'm going to go up 5, try to get closer to that line. 1, 2, 3, 4, 5. To the left 3. 1, 2, 3. There's the point of intersection. So this is the scenario where I have exactly one solution. It intersects at the point negative 3, comma 2. So that's solving systems by graphing. Number 4, solving systems by substitution. Okay, the thing you have to do for to use substitution, the one thing you need is to have a variable isolated or solved for, which we do. We have y solved for. So I'm going to take what y is in that equation and substitute it in for y in the other equation. So I have negative 3x plus 3, and for my y, I'm putting in parentheses, equals 12. And in those parentheses, I'm going to substitute what y is equal to, 3x plus 14. Then I'm going to distribute the 3 and solve for x. So I have negative 3x, positive 3 times 3x is a positive 9x. Positive 3 times 14 is going to be positive 42. Combine my like terms, negative 3, positive 9x, positive 6x. Subtract 42 from both sides. I get 6x equals negative 30. Divide both sides by 6, and I get x equals negative 5. So we're in the scenario where we have exactly one solution, right? Yep. I would definitely choose the bottom equation. So y equals 3. I know what x is. So I'm going to put parentheses there, plus 14. My x, negative 5. I have negative 15 plus 14, which is negative 1. And the last method we had was elimination. Now, elimination means I'm going to add the two equations together and eliminate one of the variables. But if we look at our two equations, if I add those together, I'm not going to eliminate any variable. So I'm going to have to choose one and multiply at least one of the equations by a number. Now, we can eliminate the x's because we have a 1 here and a 2 there. I could just multiply the x by 2 and I'd get rid of it. Signs are different. In fact, it'd be positive 2. I could also get rid of the y's because 2 is a factor of 10. That would be easy too. Either one. I'm going to choose the bottom one and I'm going to multiply it by 2. Now I have to distribute that 2 to every term inside, even the one after the equal sign. 2 times negative 1x is negative 2x. 2 times 10y is a positive 20y equals 2 times negative 24 is negative 48. Then I'm going to bring the other equation down. So I have 2x minus 2y equals 12. Now I'm going to add these two together. And what happens is I eliminate the x's. 20y plus negative 2y is a positive 18y. Negative 48 plus 12 is a negative 36. Divide both sides by the coefficient 18. And y is going to equal negative 2. So again, I'm going to have an intersection at exactly one point where my y equals negative 2. Now I got to figure out what x is. So I'm going to go back to the original equation, and it doesn't matter which one we pick. I'll pick the top one. 2x minus 2, and again, I'm going to substitute in y equal 12. My y is negative 2. So I have 2x, negative 2 times negative 2 is a positive 4, equal 12. Subtract 4, subtract 4. I get 2x equal 8, and then divide by 2. X is going to equal 4. So they intersect at the point 4, comma, negative 2. Okay, 1.5, compound inequalities. When they're squished together like this, it's an and problem. We're still having issues determining whether it's an and problem or an or problem. Ors, when we're dealing with just simple compound inequalities, you'll have the word in there or. This is a big thing too with a lot of common mistakes. Or problems, either a parenthesis or bracket, and they shade towards the infinities, like boat oars. And problems are the sandwich problems where you're going to either have parenthesis or bracket, and you shade in between, like a sandwich, right? In between, enclosed. Huge issues with these. Okay, let's go ahead and solve these inequalities. These are two separate inequalities. So I'm going to subtract 7 from both sides. Remember with inequalities, if you multiply divide by a negative number, then you flip the signs. Here we're subtracting, so we don't have to worry about the sign. 12 minus 7, 5. It's an OR problem. Add 2 to both sides here. Add 2. So I get n is less than, now, negative 2 plus 2 is 0. 0 is a number. So use it. Kind of, a lot of students make mistakes and they get a 0 there. They think they did something wrong and they leave the problem. 0 is a number, so use it. Then we have to graph them. So draw a line, put the smaller number first. Let's see, 0 is smaller than 5. It's an OR problem, so I know we're going to shade like boat oars to the outside, to their infinities. Then I got to go back and look at the inequality sign. If it has an equal sign, I use a bracket. The 0 does not, so it's a parenthesis. This one does have an equal sign, so I have to use a bracket. Interval notation, just read the graph. Negative infinity, which always gets parenthesis. Then it gets going to go out to 0 here. And then it hits another parenthesis. My space, I always like to think, well, that's where the union symbol goes. Then I hit the bracket, 5 out to positive infinity, which always gets parentheses. So there's my graph of an OR compound inequality. Okay, the AND problem. Now, the biggest mistake with the AND problems, they're squished together. A lot of students try to get rid of this 7. They go left to right. So they start subtracting 7. We have to work from the middle out. Okay? We have to get this N by itself. So I'm going to subtract the 4. I'm going to work from the middle out. So the middle, I'm subtracting 4, then go out to the sides. I'm going to subtract 4 from each side. Still going to stay in the middle. These cancel. Going to bring down my N, then work out to the sides. 7 minus 4 is 3. I'm subtracting, so I'm going to keep the sign. So it's greater than or equal to. Go out to this side. Negative 4 minus 4, negative 8. Keep the sign. Ends by itself. I'm done. This is an and problem, so I know I'm going to shade in between. I have the smaller number, negative 8. The larger number is 3. I know I'm going to shade in between. Let's see, the 3 gets a bracket because of the equal sign. The negative 8 gets a parenthesis, no equal sign. Interval notation, parenthesis, negative 8, comma, 3, bracket. All right, absolute value inequalities. The biggest issue here, I think, even in the directions last time, we even put on there make 2 problems. Okay? Absolute values always has 2 problems. So you're going to have to split them up. But make sure that the absolute values are isolated first. Okay? And both of these problems, they're isolated. So you're going to split them up, make 2 problems. Now look at, once they're isolated, look at those inequality signs. Less than or equal to are and problems. Greater than or greater than or equal to are or problems. Okay? Split them up. Take what's inside, x plus 5. Now, I like taking the negatives first, so I'm going to use negative 1. Because I'm going from positive 1 to negative 1, I'm going to flip that sign. It's an and problem. Take what's inside and keep everything the same and solve it. So I'm going to subtract 5 from both sides. I get x is greater than or equal to negative 6 and subtract 5, subtract 5, x is less than or equal to negative 4. Draw your line. See the smaller numbers, negative 6, larger number, negative 4. It's an and problem, so I know I'm going to shade in between. My negative 6 gets a bracket because of the equal sign. So does a negative 4. Interval notation. Well, bracket, negative 6, negative 4, bracket. Number nine, it's isolated. We know it's an OR problem because it's greater than or equal to. So let's split it up. Bless you. Negative 4 plus x is, now I'm going to put the negative 6 first, so it means I have to flip my sign. We know it's an OR problem. Take what's inside, keep everything the same, greater than or equal to 6. Solve them. I'm going to add 4 to both sides. So I get x less than or equal to negative 6 plus 4, negative 2, or add 4, add 4, x is going to be greater than or equal to 10. Graph it. See, negative 2 is a smaller one, 10 is the bigger. It's an OR problem, so it's both ORs. See, bracket with the negative 2, bracket with the 10. See, this is negative infinity to negative 2, bracket. I like to think of that space as my union. Bracket 10 out to positive infinity. There's my interval notation. Questions? All right, page 3. Then we did some graphing systems of inequalities. Okay, we graphed those. And then the solution was the intersection of the areas. So first thing I'm going to have to do is draw my lines. So let's look at our first inequality. The line here, well, my b equals 3. My slope is 2/3 or negative 2 over negative 3, either way. So I start at 3. If I go up 2 and to the right 3, I get a point. Or I can go down 2 to the left 3. Now, remember, with inequality systems of inequalities, we have solid or dashed lines, right? Do I have a solid or dashed line here? Solid because the equal sign there. Yep. Do I shade above or below? Below because it's a less than sign. Okay, the other line, let's see, I'll use orange. Hopefully it'll show up. Okay, my y-intercept, -1. My slope is -2 over 3 or 2 over -3. Okay, so I'm going to start at -1. If I go down 2 to the right 3, there's a point. Or I can go up 2 to the left 3. Solid or dashed line. Dashed, there's no equal sign. Shade above or below. Below, because it's a less than. And my solution is the intersection of the area. So you have to highlight it somewhere. This is my solution area. Number 11, they're in standard form. We need to, I would highly suggest, so that we can follow our process, to put these in slope intercept form. So 3x plus y is greater than or equal to negative 3. Going to subtract 3x from both sides. So I get y is greater than or equal to, I'm going to put my x term first, negative 3x minus 3. So that means my y-intercept, negative 3. My slope is either negative 3 over 1 or 3 over negative 1. I'm going to go ahead and graph that line. See, negative 3. And I'm going to go up 3 to the left 1. Up 3 to the left 1. Solid or dashed? Solid because of the equal sign. Shade above or below? Good. Because it's a greater than above. Okay, do the same thing with the bottom one. So x plus 2y is less than 4. Subtract x from both sides. I get 2y is less than negative x plus 4. Divide every term by 2. So I get y is less than, don't forget there's a 1 there. So negative 1/2. I'm going to pull that x out to make it look pretty. Positive 4 divided by 2 is positive 2. So my y-intercept, 2, slope is either negative 1 over 2 or 1 over negative 2. Okay, see, y equals 2. I'm going to go down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2. Solid or dashed? Dashed. No equal sign. Shade above or below? Below, it's a less than. And my solution is the intersection of the shaded area. And I'm going to highlight that area.
That confused me for a moment to the camera.
Yeah, I'm sorry. Yeah, it's got a little bit of a lag on it.
I was so
Yeah.
confused. I'm like, am I having a eye thing or whatever?
No, the camera does have a lag on it. All right. Um, exponents.
I have a question.
Yes, ma'am.
I don't know if it's just me, but like once it's like diagonal, like number 2 by 11, it just confuses me on if it's above or below because it's not really like the first one.
Okay. Um, greater sign. I think I even put it in here. Less than or equal to shade below. Okay.
Yeah, I know that, but it's like, what do you? What,
Okay, think of it this way. Y, okay, we put it in slope intercept, right? Y is greater than. So when you see y is greater than, think of those numbers that are going to be going up, right? Greater. When it's less than, and we got y is less than here, it's going to be all of those y values that are going to be less or shade below because the y values go lower.
okay, never mind.
Okay. That's the way my brain works. but a lot of students like, hey, above and below just works for us. But I have to actually think of what that y value is, and then I shade what is the solution in my brain for that. So it all depends on how it works. All right, let's get through these a little quick. Let's see, number 12, I'm going to group the numbers. I have A's and then I have B's. The numbers, I just have the number 3. I have the number A cubed times A to the fourth. And then I have B to the fourth times B to the first. When I have the same base, I add the exponents. So I have 3, A to the 3 plus 4 is 7, B to the 4 plus 1 is 5. My answer. This is power of a power. Remember, if there's no exponent there, it's a 1. So I'm going to distribute that 3 to every exponent. So I get 2 to the 1 times 3 is 3. A to the 2 times 3 is 6. And B to the 2 times 3 is 6. If you want to actually multiply out that 2, that's fine. B cubed is 8. Number 14, let's see. There's nothing I can do with the 3 and the 2, right? I'm going to leave the 3 and the 2 there. In fact, there's nothing I can do with the x because there's no x in the numerator. But the y, don't forget, there's a 1 there. So when they're dividing, I subtract the exponents. So 1 minus 2 is negative 1. Where's that going to go? In the denominator with a positive 1. Okay. Because think of that as over 1. Also, another way to think about these, my y exponent is bigger in the denominator, so that's where my y is going to end up. Just another way of thinking about it. Okay, 15, again, is all multiplication. So what I would do, put my numbers together, my m's together, and then my n's together. So I have 2 times 4, m to the fourth times m squared, n to the negative 1 times n to the negative 3. Now I add the exponents, right? 2 times 4 is 8, m to the 4 plus 2, 6, n to the negative 1 plus negative 3 is n to the negative 4. Can never leave my answer in negative exponent, so I'm going to put it over 1 and then move that n to the fourth, negative 4, to the bottom and make it positive. And then finally, we did some factoring, right? Some simple factoring. We did common factor out common factor, and then we did factor completely with no coefficient for the x squared. So number 16, what can I take out of both? I'm going to look at the numbers, 35 and 28. 7, right? I have 2 A's in the first term, 1 A in the second term, so I can take out 1 A. 35 divided by 7, 5. I'm taking out one of the A's, so I have 1 left. 28 divided by 7, 4. and I'm dividing out the a's, so I'm done. And the last one, 17. I have no coefficient for x squared, so the only way I can get x squared, x times x. Then I look at the factors of 90. So I have 1 times 90, 2 times 45, 3 times 30. Let's see, 4 times 15. Does that work? No. 20. See, 2, 8, 10. Nope, 4 doesn't work. 5 times 18. See, 6 does, yeah, 6 does work. 6 goes into 9 once, 15. 7 doesn't work, 8 doesn't work, 9 works. Well, there's a lot of factors for 90, right? Now, they have to multiply to a positive number. So they could either be a positive times a positive or a negative times a negative. They're going to add up to a negative 9 or positive 19, so they both have to be positive, right? Which two factors are going to add up to 19? Yeah, there's my answer. Positive 9, positive 10. Now, obviously, your quiz is not going to be that long, right?